Well, let's welcome our speaker, Dr. Andy Miller from Belmont University, I believe.
Yep.
And let's learn a little bit about SageMathCell as a DE toolbox. Thank you.
Yeah, well, thanks for having me today virtually. Yenping and I, just before the talk started, were chatting a little bit about her experience or lack of experience with SageMath. And so I'm not sure what it's like in the room here, so we can use a little Zoom interactivity. So just out of curiosity, if you have experience with SageMath, so you're familiar with how to use it, whether in calculus or any course at all, just raise your hand with the Zoom reaction button, I think it is these days.
We have one.
I see one. Okay, well, that's good. That helps me know a little bit about what to talk about. What about other systems like Maple or Mathematica? You can raise your hand there. Okay, more people there. Okay, good. I see, I guess I'm leaving out MATLAB. So MATLAB would be another big one for DE. Who has experience with MATLAB? Okay, so a few people have experience with a few of these computer algebra systems, others maybe not any at all. So I'll start with a quick, sort of just the intro to SageMath, and this is a link to their webpage. It's a free open source software system. It's meant to duplicate a lot of the functionality of some of the big, expensive commercial software like Maple or Mathematica, but also other things like MATLAB. So you know that if you're familiar with Mathematica and MATLAB, they do very different things. MATLAB is generally for numerical computing mostly, but not only. Mathematica can also do both, but leans a little bit more towards symbolic. Sage can do both. And so, for example, Sage can calculate derivatives, it can calculate integrals, it can plot, it can do animations, all sorts of things. And it can also solve differential equations. And so we'll see, I think it'll flow a little bit better if you just see some examples of actually what Sage does in a little bit when I switch over to a web browser. But just know that that's what SageMath is. It's a free software. The other interesting thing about Sage that's different than Maple and Mathematica is that you access Sage through a web browser. So if any of you have used like Jupyter notebooks with Python, actually a very common way to interact with Sage now is through a Jupyter notebook using Sage as the kernel. If you're not familiar with that, just know that the way you work with Sage is instead of installing something on your computer and running it locally, the Sage software runs on a server that you connect to over the internet. And there are a few different ways to do that, which I'll talk about in a second. But also just to know what are some sort of tools that SageMath can do that you might find useful in an introductory DE class. It can solve differential equations. It can plot slope fields. It can do streamline plots, which I actually wasn't familiar with until I saw a Sage documentation page once. It can do Euler's method, which and it's correctly documented as for pedagogical uses only. We all know it's not a good general purpose numerical solver, but of course it has the Runge-Kutta fourth order method built in. And also, when you get to solving systems and doing eigenvectors and eigenvalue analysis, Sage can compute those automatically as well. So these are all the basic computational tools you might need in a DE class. The different ways that you access SageMath, so over a web browser, like I said, Sage runs on a server. So where do you put that server software? Many years ago here at Belmont, we actually installed a local server for Sage. If you have somebody that can install software, it's not too hard, but I know not all institutions have that. The drawback to that is you are then responsible for maintaining it, updating it, doing software backups for any of the notebooks that are stored on the server, and all of that. There's also a commercial free, but also subscription service called CoCalc, which they provide the Sage server and lots of other stuff You can have access to that for free and store files there and run SageMath and build notebooks, but it's not friction-free unless you pay. So there are some limitations on computation with last what I was saying. There's limitations on how much memory you get. You may run it a little bit slower. It has a little reminder text of that. So I have a subscription to CodeCalc because I find it really useful. But I know that's not practical for students unless you find some way to run a class. If you can subscribe a class to CodeCalc for like a semester, but again, it's not free. So you'd have to have some sort of institutional resources for that. So that's got its drawbacks. If you want to actually have students do computer labs and you want to grade them, there's a lot of stuff built up on CodeCalc to collect homework from students, grade it, return it to them. So there's a lot of functionality there if you want to go that route. So what I'm talking about today is a third option. It's called SageMathCell. So this is a website that someone else, it's a Sage server that they run, but instead of having a full notebook interface, it will compute any Sage commands you can fit in one cell. So any set of lines in one box of computation. So it doesn't have all the fancy Jupyter Notebook stuff, and it's not persistent, meaning you can't save your work from stage to stage, but you can share a Sage cell. So we'll go to the SageMathCell server and look at it in just a second. But what you'll see when we go there is that you've got a little box where you can put commands in and run them. And then once you execute it and evaluate it, you have output down here. And then there's an option here to create a link to your cell. And I must admit, I don't know how short or how temporary the short temporary link is because I use the permalinks. And so they actually code all the text you put in the cell as part of the URL. So it's a very long address, but you can save it and link it for students, and then they can open up that text at any time. And we'll see how that works in a second. And Joe, I just want to let you know, I see your question in the chat, and I think I might be able to give a partial answer to that as we go. All right. So what I'm going to show you in a second is ways that I use SageMathCell to essentially create links to single computations that my students can edit, and then they can use it as a computational tool. So with that, I think we should probably just pop over to my browser, and I need to switch sharing. Okay. So everybody should be seeing my web browser now, is that right?
Yes.
So this is SageMathCell right here. So you just type some Sage code below, and I'm going to zoom in a little bit to make it a little bigger. Might be easier for you to see. So let's say I wanted to plot something. Let's say I just want to plot e to the x. So I can just type plot e to the x for x from 0 to 10. Right, so that's basic functionality there. And you plot, it takes a little bit of time, and then it generates the plot. Okay, we'll see more fancy stuff in a second. I just wanted you to see a live SageMathCell. And then if you wanted to share that code with students, you would click the share button here. And I've never used the QR codes, but there's a QR code that it uses. But I click the permalink, and you'll see that what happens is it up here in the address, you'll see it's generated a big long string. And so now if I cut and paste that, so if I copy that and open up a new window and paste it in, you'll see it'll take me back to that cell and execute it with that text. So that's a way to save a SageMathCell. So if I made edits to it, like let's say I wanted to plot e to the 2x. All right, so now that's a new plot. It looks a little different, not a lot different, but I've changed the plot. It won't save that. So then if I go back and execute, go back to the same URL, so I'm just going to enter again, you'll see it doesn't keep that. So this has its drawbacks and benefits. One benefit is that students can never screw up a link, right? So if they get something all messed up so that it's not working anymore, they've messed up some syntax, they can always just open the link again and it'll come back to a fresh working page before they do that. The drawback, of course, for students is it doesn't give them a way to save something they want to use. It really only exists in this browser session. So that's the basic, basically how you can use SageMathCell to provide working cells for students. You put the code in, you save the permalink, and you share that with students. And so I'm going to show you a, so here's an HTML page. Right, yeah, so Phil makes a good point that if you want to have shorter URLs, you can use URL shortening services because the way I provide these links to students, so you're looking at an HTML page right now I created for this presentation, and it is linked from my our department website if you want to have access to this after the talk. But the way I generally do it is I put these links up in our course management system. And so students have access to that. And so I don't bother with shortening the URL personally, although you certainly could. You could give them all meaningful names. But that's a great idea. Okay, so let's go through some of the tools. So I organized them in, sort of classic organizational method, analytic, qualitative, numerical. And I don't think I'll go through all of these because I want to give people time for questions, but let's look at a basic example in each area. So as an analytic tool, if you click that link, you open up a cell that will solve a differential equation and will find the solution analytically. So this is an analytic solution. I believe it uses Maxima. That's the code it uses for solving it. And so up here at the top, I organize these cells so there's a section where students can edit their work. And then down below is where all the execution is. And so when I show this to them, I generally tell them, here's where you would change stuff. And I try to put comments in to indicate what you would change. And here is where your output comes from. And here we're solving the differential equation x prime equals x plus t with initial condition x of 0 equals 1. And as I mentioned in the web page, my current textbook uses x as the default dependent variable and t as the default independent variable. So that's how all these cells are set up. So you can do analytic solutions. Let's go back to another one. Qualitatively, of course, you have slope fields you can plot. It's just plot slope field. You put on the right the equation for your differential equation, and you can plot a slope field. You can also plot streamlines, which is kind of neat. So basically, a streamline plot is instead of a slope field, it actually creates a bunch of numerical solutions to the differential equation and plots several sections of them. So it's sort of like an automatic ensemble of solutions to a differential equation with just one command. Oops, I closed instead of used the back window. This is kind of a fun one, just to show you how fancy you can get with plotting on Sage. So our textbook talks about using isoclines to help draw a slope field by hand. I'm not sure why it's not evaluating. I just have to hit evaluate. Oh, I see a little wheel spinning. So this is a graph. I recreated a picture from our textbook. So what you're looking at here is a slope field for a differential equation, several numerical solutions, and all the blue curves are the isoclines. So along those blue curves, the slope of the solutions are equal. So those are lines of constant slope. So that's just kind of fun. And then you do have numerical tools. So there's Euler's method. By default, it outputs a table for values that you give for a step size. The tables, it's hard coded into Sage that it's X, Y, and H for the independent, dependent, and step size variable. So I had to notate that to students. You also have the improved Euler method. If you want to demonstrate it, you have to code it yourself. It's not built in. So this is an example, if you know Python, that you can just write a Python function in the Sage cell and include it. So you can include all sorts of stuff, define new functions. This is the input, and this is the output line, and it creates a table or a list of values for that. And then, well, we all know that it can do numerical solutions as well. And that's available. So somebody asked about parameter estimation. So let me say that yes. Now, as far as sensitivity analysis, I'm not sure. I don't know how automatic it can do it, but since Sage can do generic mathematical computations, including ones you write, you might be able to write something for it. But it can do parameter estimation sort of out of the box. So this is an example I built for students for a particular model using, actually one of the semi-ODE models on, I think this is the steeping a perfect cup of tea model. This is some data from that. And this is an example of how they can fit data to a model. So you can see that the basic Sage command is find fit, and you put in the data and you enter a description of the model with some variables, and what fit returns is a dictionary, a Python dictionary for the variables you put in for the best estimate. So it can do parameter estimation out of the box. Fitting models is there if you set things up. And then this is just a plot of the data and the model for students to see. It can do other, sometimes you might want to make just special purpose stuff. So when we talk about the SAR model, I build a specific cell just to do SAR models and label it so they can see a plot as we change various parameters of SI and R. So that's the basic functionality of, and again, all of these links, these are just hard encoded links to SageMathCell with horrendously long URLs that just encodes all the text. You can also make notebooks available to students. So just so you can see what that looks like, this is a notebook I made and shared on CoCalc. It's not live because when you share a notebook on CoCalc, it doesn't do the computations. But this shows you that with a full Jupyter notebook running Sage, you can include documentation around all the cells. You can write in LaTeX. So you can really make it much more user-friendly if students can run notebooks. Now notebooks can be turned into full HTML pages. And as the last thing, I just wanted to give you an example of that I used for another class. So I hope that opened up. Well, let me get the link copied. Well, it's not working. I think I'll just type it in. I've been to it recently. It's not that one. Pardon me for not having this open up. So this is a web page. It's HTML. It's running off of our local web server, but you can see that it has live Sage cells embedded. And so there is a process that you can do that through the SageCell server. You can upload Jupyter notebooks to it, and it'll turn it into something that when students click execute, it actually uses the SageMathCell server to run the code, and they report it back on your web page. So this was an example about modeling seashells. So when you execute the code, it generates three-dimensional graphs of a parametric surface that's meant to model a seashell. And it takes a little while because there's a lot going on there, right? So if you get to a point where you're working with full Jupyter notebooks and you want to include a little more documentation along with computation for students, this is a way you can do it. There is a way to turn those into live executable web pages. Okay, so I think maybe that answers Joe's question, and I know this is about the time I was supposed to wrap up for questions, so I'd be happy to hear any thoughts or questions people have.
Thank you, Andy. Anyone have questions? You can, unmute yourself and speak up.
I don't have a question, Andy, but it's pretty cool. I hadn't been familiar with SageCell, and so it's been fun to watch.
Oh, good. Yeah, so one of the things, I don't know if everyone heard, but one of the things I was talking with Yenping about at the beginning was the biggest, I think the steepest part of the learning curve for SageMath, like any free open source project, is that the documentation isn't as nice as it would be for something like Mathematica or MATLAB. So there's a little bit more work on your own to do that, which is also one reason why I try to provide a lot of working code to students, because the documentation is also not as friendly to them. And I just switched back in case to the slides, in case anybody wanted to write down the URL to what I'd created there. So that one is a nice short URL because I created that one myself.
Do you mind paste it in the chat? So
Yeah, I was trying to cut and paste from it, but I can do that in the chat. I can just type it.
thank you so much. Just out of curiosity, do you test students on like programming skills with this by any chance, or it's mostly just because I'm teaching differential equation right now, and my students keep asking me, how would you test Euler's method? Like, are you gonna ask me to fill in the table, calculate 3 steps, or you really want me to write the code like during the test, something? So yeah. So when you ask your student to work on SageMathCell, I am guessing a project or something is more natural,
Yes.
but can you test about it by any chance? Or
Yes. So I have been teaching my courses for the last few years very heavily project focused. That was partially a response to teaching remotely. But I actually don't have exams or quizzes in my DE courses. They do weekly homework, and then they also do projects throughout the semester. And in the projects, I do lead them. The homework problems require technology. Some of them do with our textbook, and the projects require technology in some cases too. And so this is the tool that they're using, but it's not in class. Now, as far as testing numerical methods, like, yeah, sometimes on a test, when I would write a test for Euler's method, I would ask them to do like 2 or 3 steps. But of course, I think it would be kind of silly to ask somebody to do Runge-Kutta method by hand, even 1 or 2 steps. So yeah,
Yep.
this is what I use for out of class work. Oh, I was worried about that. Let me troubleshoot the second link real quick. Oh, I forgot the Miller part. That's what it is. I forgot my last name on the first one.
any other questions from our audience here?
I will say, while people are thinking, so at 3:30, so one of the other presentations, the one that Phil's giving in this room, is on using Jupyter Notebook and R Markdown. So that would be a good exposure if anybody's interested in the notebook side of Sage and all that. That would be a good introduction to that, because everything that Phil talks about relating to Jupyter applies with Sage. It's just you run Sage in the notebook instead of something else. Adam, do you have your hand up? Do you have a question?
Sorry. Thank you for your presentation. I've once used, I don't know whether I've used Sage, or I was actually working on Jupyter Notebook, and we were just exchanging code from Sage and Notebook. So I thought Sage was part of Notebook and Jupyter Notebook, until today that I've seen that it's a separate toolbox altogether. So thank you. So like the question is, if you are running something in Python, for instance, and then you encounter a lot of problem, it's easily to get solution out there online. But I don't know much about Sage. I don't know if they have the same community that they share problems and then solutions in Sage.
Yes. So there are a lot of people that use Sage.
Okay.
So if you have, when I run into syntax problems, like if I Google, how do I blank in Sage Math, I usually get a result in the first 5 search results. Questions about Sage show up, for example, on Stack Exchange, which is that's where everybody posts tech questions these days. So there is a community of people out there. There are people writing textbooks too. So Gregory Bard, if I remember correctly, has a book called Sage for Undergraduates. It's actually a good intro book for undergraduate mathematics for any user of Sage. And the first edition is free on his webpage as a PDF. It uses an older version of Python, which makes some of the syntax wrong in his examples. He has a new edition that's using Python version 3. So there are textbooks written that refer to Sage. There are online textbooks that use Sage as a computation. There are a lot of people using it. There's usually some sort of discussion about Sage at one of the annual math meetings.
Okay, thank you.
Thank you. Any other questions? Well, I am sure if there are other questions, you know how to contact Andy through email. So, well, let's just thank our speaker again and take a bio break or whatever, and we can come back in 2 minutes for Phil's talk. Thank you very much, Andy.
Thank you.